Hi, this is John, and welcome to lesson number 1 on Soft Cell Electrical School. The first lesson is, what is electricity? Well, simply put, electricity is the flow of electrons through a medium. That medium is usually copper or aluminum wire of various types and sizes. Now, there's different types of electricity. There's plasma, static, direct current, and alternating current. Special emphasis on direct current and alternating current because plasma and static really are not what we're going to be talking about here. There are many different sources of electricity. Some of them are static electricity, as seen in lightning, photoelectric, which is photons converted to electrons, electrochemical, which would be like a battery or a hydrogen cell, transformer, generator, and an alternator is like a generator on steroids. The three main sources of electricity that we're interested in are not anything that I just mentioned. They are main panel, sub-panel, or junction box. On rare occasions, you might be using a transformer, but this will probably be a low voltage application. There's two types of electricity that are going to be used within the home. That's alternating current and direct current. On rare occasions, you will be using direct current. Mostly, about 99% of the time, we're going to be using alternating current. But first, let's go over direct current so that you know what that is. Direct current flows from one point to another. It flows from the negative to the positive, which is the opposite of what people think. Think of positive as the attractant. It is attracting electrons from the negative or repulsive source. Direct current goes in one direction. It has no cycles. It has voltage and it has amperage. You have positive and negative, and electrons flow from the negative to the positive. And again, no cycles, only voltage and amperage. The main thing you're going to be dealing with as an electrician is alternating current, commonly known as AC. Basically, it's called alternating current because the current alternates. It alternates at a given time sequence. In America, that's 60 cycles per second. In alternating current, don't think in terms of positive or negative. Think in terms of hot or source and neutral. So you have hot and neutral. The neutral only gives the source the ability to pulsate at 60 cycles per second. Another way of thinking of this is through the American Indian. Okay, let me illustrate. Before I go any further, I'd like to say I have the deepest respect for the American Indian, and I only use this illustration because it's the best way I can think of to really explain how energy is manifested in alternating current. So let's look at this very crude diagram that I've commissioned here. And you have a bow that is looped through a staff. Now this bow goes back and forth, okay? It alternates, all right? This alternation causes a spinning of this rod into a combustible substance. Their energy is produced, thus creating a fire. Now, think of this back and forth motion as electron flow, okay? So, at 60 cycles per second, basically this bow would be going back and forth 120 times every second, because a cycle is actually split into two. So, but basically you'd be looking at 60 cycles per second. That would be one very, very quick Indian. And the back and forth motion produces energy. That would be one way of looking at alternating current. Now, let's look at another diagram, and this one's not going to be a very good diagram, which would illustrate direct current using the same principle. And you'll see why alternating current is much more efficient than direct current. So now we come to direct current. Okay, direct current is current that goes in one direction. There's no alternation, there's no cycles, there's a constant flow of electrons. Okay, it goes in one direction. All right, now the principle is the same. You've got your stick here, which is getting turned instead of back and forth, it's going in one direction, and the energy is manifested down here where you create a fire. But it's terribly inefficient, and although it's not the same here as the way it works in electricity, the idea is the same. Direct current is not efficient, especially over long distances. But think of it in terms of this. Think of it as this side being positive, the attractor, and this side being negative, the repeller. So your electrons are going in one direction. Another thing to consider in direct current is there is a much higher level of resistance. And think of it in terms of this. When you're looking at the bow, one Indian can operate that bow. How many Indians would it take to keep this circle of rope going? At least two. And you can think of it in terms of that. So that is the primary difference between alternating current and direct current. And that's why American households generally use alternating current at 60 cycles per second.